Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So my group will be presenting about Vehicle Safety Project 1. Our group consists of 3 people, which is Muhammad Afiq, Zharfan bin Azizi, Muhammad Muizzuddin bin Nawi, and myself, nicknamed Amyra, Adilla, Binti, Khairullah. So this project requires a simulation of the crash test process. The simulation was carried out using SolidWorks software, and the model frame used was a simplified Pro2 Beza model frame. So this is the chassis of vehicle. We chose Pro2 Beza because it is the national car, and also this is the simplified one and we created it in SolidWorks. So the first figure on the left shows the completed specifications of the chassis used in this simulation, and it is in millimeters unit. And on the right depicts in great detail of the model information data obtained from SolidWorks. And simulation method, the first one is we created drop test study. Second is apply material, and then creating mesh, and also set up the study, and lastly we run the simulation.
Impact in terms of stress and deformation on the structure. Deformation in front of Prodobeza shows the amount of structure damage that occurs to a vehicle during a simulated collision with an object, such as a wall or another vehicle. This deformation reduces the amount of force that is transferred to the occupants of the vehicle, helping to protect them from serious injury. The amount of deformation that occurs during a crash test is important because it can help predict how a vehicle will perform in real-world collision. If a car experiences too much deformation, it may not be able to protect its occupant effectively, and the likelihood of serious injury or death increase. On the other hand, if a car experiences too little deformation, it may transfer too much force to the occupants, resulting in more injuries. Next, the A-pillar. The A-pillar is an important structural component of a vehicle, providing support for the roof and protecting the occupants in the event of frontal collision. During a frontal collision, the A-pillar is subjected to significant forces, which can cause deformation and stress. Deformation in the A-pillar occurs when the pillar bends or twists due to the forces applied during a collision. The amount of deformation depends on various factors such as speed, the impact angle, and the stiffness of the material. A-pillar deformation can affect the integrity of the vehicle's roof, door frames, and windshield, which can increase the risk of injury to the occupants. Stress in the A-pillar refers to the force per unit area that is applied to the pillar during a collision. The stress experienced by the A-pillar depends on the magnitude and direction of the forces applied, as well as the geometry and material properties of the pillar. If the stress on the A-pillar exceeds its yield strength, it may cause permanent deformation or even fracture, which can compromise the safety of the occupant. Next, the sides of the vehicle. During a frontal crash, the sides of the vehicle can experience high stress due to the forces generated by the impact. Frontal crashes can cause the vehicle to deform and buckle, transferring energy and stress to the sides of the car. This can result in structural damage, which can be particularly dangerous for the occupants of the vehicle. The forces generated during a frontal crashes can cause the sides of the car to bend, twist, and deform. The amount of stress experienced by the side of the car depends on the speed and angle of the collision, as well as the stiffness and strength of the material used in the car's construction. The sides of the car are particularly vulnerable to stress during a frontal crash because they are less reinforced than the front and rear of the car. In many cars, the sides are made of thinner sheet metal and have fewer structural components to absorb the energy from a frontal impact. This can cause the sides of the car to deform and buckle, which can increase the risk of injury to the occupants. Thank you.
Hi, Assalamualaikum. Next, I would like to continue on the last chapter, which is the impact that can cause injury to the passenger or the driver. So, for the impact of this crash test, it was discussed for A, B, and C pillar. A pillar, which is the front, which is at the side mirrors. B, B pillar, which is attached with the seatbelt, and the C pillars, the rear passenger seatbelt area. So, the deformation and stress result show certain area that were impacted from the crash test. For the deformation result, shows that the changes in frame of the model. So we can see from deformation result, it shows that the displacement of the material may vary at the different area of the vehicle. For the stress result, it shows that the stress occupied at the certain area. So we can see from our result, it shows the colors of the body structure. Next, we cover the first one, which is the deformation result of the crash test. So we can see from the structure of our crash test simulation, it shows that the pillar A has higher deformation compared to B and C pillars. So we can see from the red color. From the red color, it shows the greatest displacement, and followed by the orange and the green. So based on the deformation result, the A pillar shows the greatest deformation compared to B and C pillar. The result of A pillar deformation indicate that the rigidity of the roof structure at low level, means that the A pillar should have high strength to support the roof structure. In the event of crash, in our real life, the role of the vehicle can give effect to the driver and passenger. So the effect may cause of the entrapment of the occupant in the vehicle. Also, from the crash, it can cause head injury, which may happen to the driver and front passenger. So we can see back from our result, the front passenger and the driver is at the risk because it shows that the greatest deformation at the A pillar and roof structure. Next, we move to the next is the stress result of the crash test. So stress result, it shows that how much stress at certain areas of the vehicle. We can see in this figure the greatest impact of the crash actually at the doors of the vehicle, especially the rear doors experience covers almost all the maximum stress. But in this result, we will cover also for A, B, and C pillar. So the stress experienced by the pillar increasing from C, B, and A pillar respectively. It means that C has the least stress, followed by moderate of B pillar, and the highest among pillars is the A pillars. So the stress on the pillar affect the most on the top of and bottom of the pillar. So we can see at the A pillar, the bottom and the upper, which is the top of the pillars, experience high stress. At the B pillar also, we can see top and bottom experience high stress. From C, just lower parts as higher than the rest of structure, rest of C pillar structure. So the area of the vehicle door experience the most stress. It may because of the distribution of impact from the front structure to the whole body structure. So we can see the doors, or the stress on the doors almost covers all its structure. So the rear seat is greater one than the front door. The occupants might experience impact lower parts of their body. So the effect may cause injuries from bottom of hip and lower, especially the rear passenger. So the back seat occupant might experience more impact than front seat occupant. So we can see the rear doors has more stress covered than the front doors. That's that for me. Thank you.